Today's lesson will be about solving quadratic equations. To solve quadratic equations, we are going to use the zero product property. So the first thing we'll do is we'll factor each one of our equations, and after then we are going to figure out what our solutions will be. A product will be zero if one or the other factor is zero. So in the first equation, my one factor is x plus 3. So x plus 3 equals 0. If I subtract 3 from both sides, x will equal to negative 3. The second factor is x minus 1. If I make it equal 0 and I add 1 to both sides, x will equal to 1. So the two solutions to this quadratic equation are negative 3 and 1. In example 2, the first thing I need to do is I need to factor. So I use the diamond, negative 2 and negative 8. The two numbers that add to negative 2 and multiply to negative 8 are negative 4 and 2 over 1x. So the factored form will be x minus 4 times x plus 2 equals 0. So the first solution will be x equals 4, and the second one is x equals negative 2. So here are the two solutions to this equation. In the next problem, the first thing I need to do is move the negative 49 to the opposite side. So x squared minus 14x plus 49 equals 0. I could either use the diamond or recognize the pattern that this is x minus 7 to the second power, which equals 0. So if I make the factor x minus 7 equals 0, x will equal to 7. And this is a special case where x equals 7 is a double root because we have two factors of x minus 7. So x equals 7 occurs 2 times. In this next problem, again I'm going to be able to either use the diamond or recognize the pattern. If I look at the pattern, this is a perfect square. So I have 3t minus 2 to the second power equals 0. If I verify the middle term, I have to look at 3t times negative 2 is negative 6t times 2 gives me 12t, which is all correct. So I need to solve for the roots of the quadratic equation. 3t minus 2 equals 0. 3t equals 2 and t equals 2 over 3. Again, t equals 2 over 3 is a double root since I have a perfect square with the same two factors. In my last example, I have the sum and difference pattern because I have a perfect square in the first term, and then I have subtract a perfect square in the second term. So this is 2u plus 1, the sum of the two terms, and 2u minus 1 equals 0. So when I solve this, I'm going to get u equals negative 1/2 and u equals 1/2 as my two solutions. In the last two examples, we need to find the zeros of a quadratic equation or rewrite them in the intercepts form. So basically we need to factor the right hand side. So I'm going to make my diamond, and I have negative 6 and 5. The two numbers that multiply to 5 and add to negative 6 are negative 1 and negative 5. And since my a is 1, I can say over 1x. So the factored form of the quadratic equation is going to be x minus 1 times x minus 5. And the zeros will be x equals 1 and x equals 5. Or if I write them as an ordered pair, it will be 1, 0 and 5, 0. These are my x-intercepts. In the last example, again I make my diamond. 6 and 8, the two numbers that add to 6 and multiply to 8 are 2 and 4. So I will write this over 1x again, since ax is 1x. The equation will be y equals x plus 2 times x plus 4. So my two zeros are x equals negative 2 and x equals negative 4. Or if I write it as an ordered pair, negative 2, 0, and the second one is going to be negative 4, 0.